I am Dr. G. Satish Kumar, Professor, Department of ECE, Vardhaman College of Engineering. Dear students, today we are going to discuss about noise calculations in analog communication systems. So far we have discussed about different modulation techniques, and today we are going to see how the noise will be calculated in a particular analog communication system. We know that as the signal propagated through the channel, the received signal, when it comes to the receiver, then we know that a noise will be added in the channel. As the signal propagated through the channel, it will be degraded or distorted. So the noise which added we are representing with W of t, which is nothing but a white Gaussian noise. Apart from this, there are other noises that will be added due to the electronic components in the transmitter and the receiver or in the channel. So the power spectral density of this Gaussian noise, which is representing with SNF, that is nothing but N0 by 2. Where N0 is the average noise power per unit bandwidth. So when this is given in the circuit, next we are having a band pass filter. So what is the purpose of the band pass filter in the circuit? We know that the noise signal is random in nature, which is an infinite signal. So to calculate the noise power, then it is not possible to calculate the noise power of the signal. So this white Gaussian noise will be converted into a band limited signal so that we can calculate the noise power. So why we need to calculate the noise power means, to measure the performance of any communication system, one of the parameters is SNR, that is nothing but signal to noise ratio. So in SNR, it is nothing but a ratio of signal power by noise power. So to calculate the noise power, we need to make it a band limited signal. So that's why this Gaussian noise signal W of t will be passed through a band pass filter. So this is the noise signal power. Now, after passing through this signal, then what happens to it? So then it will become, the noise signal will become N0 BT. What is meant by N0 BT? BT is the transmission power or transmission bandwidth of this band pass filter. So that's why we can represent with the signal which is coming out from here. We are representing with SI and NI. So now after that, this will pass through any detection circuit. Depending on the type of the modulation we are using, this is the detection circuit which we are using. So by using this detection circuit, again we can generate a signal which is nothing but Y of t. We can get it. Say for example, if you are using a DSBSC modulation, this signal will become the DSBSC signal and the detection will be related to the DSBSC. Suppose if you are using AM signal or FM signal or say SSBSC signal, then the detection will be correspondingly, that will be AM, FM and SSBSC signal. So another important parameter is how to calculate the SNR. We have seen the types of the SNR. One type is signal to noise ratio at the input side. We call it as SNR input, or we can call it as the pre-detection SNR, which is nothing but the pre-detection SNR. So this pre-detection SNR, we need to measure it before modulation. Then another type of SNR is there, that is output SNR. The another name for this output SNR is nothing but post detection SNR. We call it as the post detection SNR. So this will be taken after demodulation. This will be calculated after demodulation. So another type of SNR is there, that is nothing but reference SNR. We call it as the reference SNR. Another type of SNR is called as the reference SNR. So after finding all these things, we can find the figure of merit. we can find the figure of merit. What is meant by figure of merit? It will measure the performance of a given analog communication systems. It is nothing but it is a ratio of output SNR and reference SNR. It is nothing but output SNR and also a reference SNR. So this figure of merit is a dimensionless quantity, and normally its value should be high. So for a given analog communication system, the figure of merit, we can FOM, we can call it as figure of merit. It can be equal to 1, it can be equal to 1, and it can be greater than 1, and it can be less than 1. So based on the figure of merit, then we can understand the performance of a given communication system. So this is the, we can call it as a receiver model. How a receiver can be modeled. Based on that, first step is we need to go for the band limited noise signal, then we can go for the different type of detection we can use. This is the introduction about the receiver model to calculate the noise calculation in a analog communication system. Thank you.